There is a very real fear right now that natural language AI is going to make traditional software engineers completely obsolete. It is driven by a trend called vibe coding, the idea that anyone without a technical background can just chat with an AI model and conjure up a fully functioning software product out of thin air. And to be fair, the hype feels justified. When you watch massive tech keynotes where an AI generates a toy operating system or a basic web app in seconds, it is easy to assume the human coder is done for. But there is a massive disconnect between a weekend tech demo and reality. Generating raw syntax to build a simple UI is easy. Architecting secure, scalable, enterprise-grade software is an entirely different discipline. What vibe coding is actually producing right now is an explosion of messy, fragile code. An AI might easily spin up a front-end interface, but it doesn't intuitively know when your specific production application requires a robust database architecture to handle actual traffic. If you look at freelance platforms today, they are flooded with emergency job postings. Businesses have tried to vibe code their way to a product, created an absolute mess, and are now begging seasoned human engineers to come in and fix it. This extends directly to quality assurance. While a large language model can write basic automated test cases, it completely fails at the complex edge case testing that requires a human understanding of how users actually break things. As this graph shows, the explosion of AI-generated code is creating a massive demand for system architects and QA testers, the human cleanup crew needed to make these unmaintainable systems actually work. We are witnessing a shift in the physical mechanics of the job. AI is taking over the repetitive act of typing syntax, which frees up the human to focus strictly on the intellectual discipline of engineering. We are moving past basic prompt engineering, mastering context engineering. It designs a system where business rules and parameters filter information. Get that context wrong, and unguided AI agents in recursive loops burn through unnecessary API calls, racking up astronomical bills. Sometimes the smartest engineering decision is realizing you don't need a massive language model at all. Often, a lightweight rule-based approach or a statistical model is cheaper, faster, and far more accurate. You wouldn't use a broadsword to slice a tomato. True engineering value today lies in dissecting a complex business problem and knowing exactly which specific tool to deploy. This brings us to a major technical limitation, highlighted by AI researchers analyzing what are called world models. Current AI architectures are incredible at predicting text, but they lack an intuitive, physical understanding of how the real world operates. Because of this, an AI cannot inherently grasp a client's unspoken business needs, navigate a physical supply chain problem, or anticipate human psychology. In the past, an antisocial developer who only knew how to write incredibly complex C++ could still command a massive salary. Today, that developer is in direct competition with AI models that hold the syntax knowledge of entire universities. What those models cannot do is manage a nervous stakeholder, translate abstract client desires into a concrete technical blueprint, or lead a cross-functional team. Since AI handles the heavy lifting of raw code generation, a developer's ability to communicate clearly and solve human-centric problems has become their strongest competitive advantage. None of this means you can skip learning the basics. Foundational computer science skills, data structures, and core programming languages are still strictly required. Top tech companies recognize this, and they are adapting their interviews. They give candidates incredibly difficult architecture problems and actively encourage them to use AI tools to solve them. But it is a test. The interviewer wants to see what happens when the problem is so complex that the AI inevitably hallucinates or creates a bottleneck. They are watching to see if you can step in and fix the underlying logic. If you treat AI output as a magical black box that you deploy without understanding, you are a liability to the company. You have to be able to read and correct the foundation. We are entering a phase where AI is rapidly accelerating scientific research. This acceleration will generate entirely new physical industries, from advanced energy grids to new transportation models, all of which will require massive amounts of new software integration. In a market expanding this quickly, reputation matters. Clients and businesses ultimately buy trust. They prefer to hand a critical project to a human they believe in, rather than relying on a faceless generation tool. The roadmap for developers right now is clear. Master your technical fundamentals, cultivate deep business communication skills, and seamlessly integrate AI to multiply your daily output. Mastering AI augmentation has become the baseline for the modern developer. In a market that no longer rewards manual syntax alone, those who leverage these tools will naturally outpace anyone still clinging to traditional methods.